guys hear me okay? Yep. All right, so yeah, thanks for attending. We're going to be talking about repurposing ESP32-based commercial products. There we go. So a lot of you guys might know me as GoJimmyPie on social media, on GitHub. Oops, got hot there for a moment. So some of the things we're going to talk about today. What is an ESP32? Quick show of hands. You guys know what an ESP32 is? Okay, everybody knows. We're going to go really fast through that part then. We'll talk about why repurpose a product. Some of the other things here, how to get started. How many of you guys have programmed an ESP32? So nearly everybody. We're going to go really fast through that material too, so all the good stuff is at the end. And so you guys know what an ESP32 is, right? So you can buy one for about $1 for anybody that might be watching after the show. The big thing about the Espressif chip is you can do Wi-Fi. You can add Wi-Fi network capability for about $1. So if you've never programmed anything on an ESP32 before, it's really good to start with a dev board. DigiKey has some Maker.io content you'll see here for some example projects, and you'll find that once you can program one ESP32, it's surprisingly easy to program any ESP32, including one that might be in a commercial product. Adafruit also has some really awesome content. If you've never been there, definitely check it out. To learn more about an ESP32, the datasheet, we all love the datasheets, right? And so I copied the block diagram here. Prominently listed first is, of course, Wi-Fi. The other thing that's interesting, runs at, of course, a much slower clock speed than your typical computer. So computationally intensive things are, of course, they take a lot longer. And so the hardware accelerated cryptographic functions, like so these ones right here, those are really important when doing TLS connections. For instance, you do really big math. It's a really impressive hardware implementation of cryptographic functions in a $1 chip, right? And so you go out to the Espressif website, you'll see they have well over 200 different devices with varying specifications. People will ask the difference between a microcontroller and a microcomputer. And so, yeah, typically does it run one program, and that'll be a microcontroller, and something like a Raspberry Pi that runs lots of things, runs Linux, is a microcomputer, right? Well, so this guy actually got Linux working on an ESP32S3. That's amazing to get Linux running on a $1 chip. And so there's a guy that helped me. I had actually never built my own Linux before. There was a guy that helped me through a chat. I had never even met him in person. He walked me through building Linux, and I have a blog at the bottom there. So if you guys want to learn how to run your own Linux on an ESP32, that's really cool. And so why? Why would you want to repurpose a commercial product? And of course, right, the reason for all of us, just because it's a cool thing to do. But beyond the things that are just because it's cool, I think everybody here, you guys are all, as being Hackaday attendees, you got something that doesn't do what you want. How many of you have electronics at home that are no longer supported by the manufacturer? Like how many of you have a whole closet full of this stuff, right? Things that have known security vulnerabilities, manufacturer rushes it out. They have no way to update their firmware anymore. And so e-waste. I mean, we all know it's such a shame, right? There's all of these really awesome products, and thousands of tons of e-waste go to the dump every year, and it's really a shame. There's no end to the number of examples you can see of just good electronics with good enclosures that probably could do really something cool, but the manufacturer just doesn't support it anymore. And so at one point, there was electronics that actually lasted a long time, right? You would buy something and you could have it for the rest of your life. It would just keep working. So do you guys have electronics that you've had for decades, right? And so, yeah, so the Sony Dream Machine, I've had mine for longer than I can remember, and it still just works. On the other hand, a while back, I bought a pair of these Squeezebox devices. You guys ever heard of the Squeezebox? So some of you, it was an awesome device, right? You could stream your favorite music on it. It connected to all the internet radio stations. Really nice box, really nice enclosure. It's got buttons. And then earlier this year, I noticed this little red icon there. It wouldn't play music anymore. And so, what's up with that? And so I tried everything, the usual cherry picking. You unplug it, plug it back in, move it close to your router. Your Wi-Fi hotspot didn't work. So, okay, what's going on? Oh yeah, shut down in January of 2024. So here's an awesome box, right? That it does something really cool, and it's completely useless now because they decided, we're just not going to support it anymore. And I don't even know what that means, support it anymore. I mean, because they didn't give me any support, right? I just needed the website to make my radio streaming service work. And so you see those there would be a server would be shut down, but they run your own Squeezebox server. But you couldn't. I can't run my own Squeezebox server. And so this is how the Squeezebox starts up, right? Free your music. Like, how cool is that? I mean, the irony of the guy that designed this way back when. If he would see that today, it's something that doesn't work. And so the list goes on, right? You guys all have equipment that it doesn't work anymore. And so I don't know whether government is the answer, but I'm a Californian, and I was really glad to see that earlier this year that California passed a Right to Repair Act, right? You buy something, you should own it, you should be able to do whatever you want with it, you should be able to repair it, and when the manufacturer doesn't support it anymore, you should be able to do something with it other than send it to a landfill. So the other thing that's cool about repurposing is, as we said with the Squeezebox, you could reuse an existing cool enclosure. So I've had a variety of experience over the years with enclosures. So I bought this. You just go out to your favorite electronic supply place and you have a project, and I've always struggled with the enclosure. You have something really cool that works on a breadboard, but how do you put it in an enclosure? And so here's something I bought. I didn't expect that little dimple in the middle of the plastic screen when it's on the cover there, the plastic cover. Didn't know that from the product description. You kind of get it, and it's like, oh yeah, that's kind of not cool. I'm an electronics guy, a computer guy. I'm not as good with mechanical stuff. So mounting the display, I see I have a little foam thing there to kind of hold it in place. That didn't go so well. I'm terrible at machining. Right? How many of you guys have done something like this where I need a hole in the side? Okay, I need a bigger hole in the side. And it just gets kind of out of hand. So part of the things about repurposing is you get to use somebody else's awesome enclosure. And anything else, right? So the Squeezebox you saw, it's got a display, it's got knobs, it's got a speaker. So not only can you entirely repurpose, we'll be talking later about putting new firmware on a device, but you can add features to something. So a while back, I wanted to learn more about CNC machines, and so I bought the least expensive CNC machines out there. It's like this, I think it's called just a 3018. It comes with kind of nothing, right? It's a Shepherd motor and kind of the super basics. It doesn't come with limit switches, so it doesn't know when it's the whole way at the end. And that's kind of the first thing. It's like, oh, that's not good. It gets to the end and just grinds, right? So I built these limit switches, and you can, if you have a 3D printer, or somebody that has a 3D printer, I designed this little switch holder, and it's you're adding a purpose to an existing device. I got a little carried away. I learned how to use Fusion 360, and it's like, wow, you can just design arbitrarily complex things, and you print it at home. And that's amazing. I mean, I've been around the block a few times, and the fact that you can design something on the computer and print a physical thing, it's just magical. And in doing so, you can extend an existing project. Oh yeah, and I didn't press the go button. But you're going to tell me how close I am to done. So we're going to talk about how to get started. I can also look at my watch. How to get started. The best way, you guys have all programmed an ESP32. You get a dev board. And once you know how to program one of the dev boards that are super easy to program, then you can pretty much program anything else, any other ESP32. We're going to talk a little bit on how to research some product specifications. There are sometimes unexpected things in a commercial product, and sometimes you can do some reconnaissance before actually having such a product. Down at the bottom there, having a security plan from the beginning. The gal that introduced me, thank you so much. I do a little bit of contract work for Wolf SSL, and they have an open source cryptographic library, no external dependencies, a couple of different products, SSH, MQTT, and these are the kinds of things that take up probably the most computationally intensive resources on your machine and potentially take up a lot of memory. And so you want to pick what sort of cryptography you're going to use up front if you're going to talk over the internet, because that's the whole point of the ESP32, right? It's got the Wi-Fi chip to talk over the internet. And so, yeah, to have something that's long-term supportable, open source, all the Wolf SSL stuff, it's all open source. You can go out there, download everything. Before we get started, a few words on safety. I'm sure that everybody here at Hackaday is comfortable working on electronics, but maybe some of the people later are not. So, and if anybody here is not, electricity in your home can kill you relatively easily. So if you've never worked on high voltage electronics, find a battery operated device. Find a friend, maybe an electrician friend that can help you. But you can get yourself into a lot of trouble, hurt yourself. Some of the safety tips, of course, you guys are probably all familiar with these. The most important one, I think, is you never work on live equipment. Never work on live equipment. Turning it off doesn't count. Make sure it's unplugged from the outlet. You got hot connectors in there. All it takes is a little finger touch, and it could ruin your day or somebody else's day. And I think the other thing, goggles. I wear glasses, but not only magic smoke gets released, but when things go pop, little pieces of molten metal go flying around. You don't want one of those in your eyes. So beyond your own personal safety, when you repurpose an existing commercial product, the manufacturer might have had something else in mind at startup time as to what the GPIO pins are doing. Like maybe you're controlling a heater or something, and is it active high or low? And we'll actually see an exact example of that later on, where what I was expecting was different than what actually happened. The other thing about the ESP32 and its health is it's primarily it's a 3.3 volt device. So many times I see people asking, well, is it 5 volt tolerant? Well, yeah, it might be, but don't push it. Not only will you shorten the lifespan of your device, but if you have a marginally operational GPIO, trust me, you can spend a tremendous amount of time troubleshooting electronics that are just marginally bad or soon to go bad, and you don't want that. Invest in a level shifter or something. Another way to get started with an ESP32 without having an ESP32, this is really cool. So the Espresso folks have a QEMU emulator, so you can actually program an ESP32 without physically having one. This is one of the most amazing websites I think I've ever seen. I don't know if you guys have heard about the Tiny Tape Out. This Walkway site here, you can actually do electronics simulation and hookup in a web browser. It's really cool. So another way to get started without having the ESP32. But really, you want to have your own dev board. And so these are two super common dev boards, and the different types are one that you see that has a little connector at the top there for an external antenna. The other one has that little tab hanging out for a PC board antenna. Each of them have their merits. Another really awesome product. This was a prize entry for my first ever Hackaday back in 2019, the ULX3S. The lattice chip you see in the center there is an FPGA chip. Many peripherals that has a DVI connector. It's got an SD. It's got buttons. The row of pins underneath the lattice chip there is for a display. And you guys are probably saying, okay, we're talking about ESP32s, right? How many of you guys know about the ULX3S? So not a lot. This is one of the most amazing chips, one of the most amazing boards ever. There's an ESP32 on the other side. This is what got me interested in it. So not only do you have the FPGA chip that you can do whatever you want, right? An FPGA is the flexible fabric that you can program to be anything, maybe a RISC-V processor. And on the same board, you can talk to the ESP32. So if you wanted to have one board that you can do a lot of experimenting with it, the ULX3S, it's really pretty awesome. A little side note, so you guys have probably heard about the latest Raspberry Pi board, the one that's on all of our badges. I had no idea that was going to be on the badges, but on that is the RISC-V processor. And so that same RISC-V processor developed by this guy Luke here, all that is open source out on GitHub, and so you can use the ULX3S to make your own RISC-V processor that's the same as the one on that new Raspberry Pi board. The Icebreaker 2, those are the two of the FPGAs that are featured as an example there. But back to we're here to talk about the ESP32. You guys are all familiar with it. You can program it with a USB port or through the JTAG. We're going to have a little reminder on safety. So you never program an ESP32 while it's connected to mains power. You don't know what's going to happen during the flashing process. It could be not cool. So Joe is here somewhere. Raise your hand, Joe. Raise your hand higher. So this guy created the TiGuard board here. This is probably my most used board ever of any cool thing that I bought. So this TiGuard board does many things. What I do with it is I use it for JTAG programming the ESP32. Do you guys, show of hands, you guys know what JTAG programming is? Okay, so most of you, cool. The important thing here, we talked about the 3.3 volts. There's a switch over there on the side. Make sure that's in the 3.3 volt position. There's a JTAG SWD switch. Make sure that's over in the JTAG position. Depends on the ESP32. You just hook these up to your TiGuard. I have a blog there down below and I actually refer to it myself pretty frequently for the pinout and such. TiGuard comes with labels on all the wires so that you just take the TDO and connect it to GPIO 15. You might want to get one of these little adapter boards here if you have different ESP32s, so you kind of quick connect. You don't need to find each one of the GPI pins individually. The only thing that's a little weird about, and it's not so much about the TiGuard board, it's about the FTDI chip that it uses. Windows will say, oh, hey, you have an FTDI chip. Let me install the FTDI drivers for you. That's not what I want. And so there's a cool tool called Zadig that I use a lot. And so what you'll want to do is you want to change the USB drivers from FTDI to the libUSBK. There are two interfaces on the TiGuard, so you want to be sure and set them both to libUSBK. Some Espresso boards have JTAG included. And I have some giveaways, not for everybody to bring enough, but I do have some for trading or just if you really want one. And so there's two USB connectors, one for the traditional UART, the other one for doing JTAG debugging. Some of the things about JTAG debugging on Windows, if when you change the drivers to libUSBK and your JTAG isn't working, just unplug the device, wait a minute, plug it back in. Lower speeds, depending on the quality of your USB cable, how long is it. You try lowering the speed. You start at a relatively low speed and work your way up. If one day you walk up to your computer, like I do on a regular basis, and my TiGuard's not working anymore. So after Windows updates, will say, hey, you have an FTDI driver. Let me install that for you. And then you go back to Zadig and change the drivers back. There are some software tools for programming an ESP32. You see them listed here. Espressif, the ESP-IDF, is of course the best because it's the most comprehensive library. Platform.io and Arduino are both available, and Espressif has their own Espressif Arduino environment. You guys have all programmed an ESP32, so you know that pretty much any editor, right? You need to edit text, compile it, flash it onto your device. So I use Visual GDB. So you guys have all programmed ESP32s. How many of you have used Visual GDB? Right, so nearly no hands. I use this all the time. It's amazing. And so it's partly because I'm a Windows developer at the day job. I've used Visual Studio for years. And the cool thing here is it gives a graphic user interface to your JTAG programming. One of the really cool things, if you've programmed an ESP32, there's a zillion different menu config settings. And so you can actually search the menu config. You see I typed in the word serial there and limited the menu config options only to those related to the serial device. You see you can pick which device you want to program. You can pick which ESP-IDF. It seems like every other day there's an updated ESP-IDF coming out. There's a specific tab for the JTAG programming, and you see this is on the debug settings tab, specifically for Joe's TiGuard. It's in the interface FTDI directory. It's called TiGuard.cfg. You see down below there you can lower the frequency at which you're programming. There's a test button there. And so you just make sure that press the test button, and if it's all successful, then you're going to know you're going to be able to single-step debug your device. And so here, it's a kind of a busy picture, but so you guys haven't used Visual GDB. How many people have used Visual Studio? So all you guys that have, sorry? Okay, good question. So this is Visual Studio, the Visual Studio. There's a community edition. I'm not showing VS Code, but that's a really good question. I do believe that you can do JTAG programming in VS Code, but this is Visual Studio. And so all those times that you've single-stepped, you set a breakpoint. You see up there in the app main, you see the little red button off to the side. I set a breakpoint there. And this is an embedded device. It's paused at that line in app main there. You can step into, you can step over. When you're paused, you can, in Visual Studio, you can hover over a variable and see what value it is. This is really amazing. You can inspect the registers. So while you're paused, you can go browse through all the hardware registers on the ESP32 and look what their values are. So you think you set your GPIO to some value in this place. Does it think that you actually set it? It's got the code explorer, a call stack. You put a breakpoint someplace. How did you get there? You see the call stack of all the things listed of how you ended up in that function. The output window, you don't need to run a separate program for the UART output. It's got GitHub integration. You can see there's a couple of red check marks that data has changed in the text files. It does all the things that Visual Studio does in IntelliSense, but with an embedded device such as an ESP32. And so now that we've covered all that, I think we're doing relatively good. All good? Faster. Okay. So what we're going to do is whether we need to start with a file new project. And the answer is probably not, because there's a lot of complexity in that. And so one of the things you want to do is find some open source software. So this guy, Akeem Peters, he's got an Apple OhmKit GitHub repository. And of course, when you're going to start with something, you start with the LED for a Blinky. And so, unlike the clock radio, right, the ESP32 projects are going to typically use network communication. You're going to want to use commercial grade libraries, open source, such as wolfSSL. And so I have a whole blog that I wrote for wolfSSL specifically on using the Apple HomeKit on an ESP32. Some of the things about wolfSSL here, I'll let you read through most of them. The important thing are the ones highlighted in red there. A tiny flash footprint and a really tiny memory footprint for doing something like TLS 1.3. So here's where you can go learn a little bit more about wolfSSL. It's a dual license, so it's free for makers. You can also, there's custom licensing if you want to have a commercial product available. There's 7x24 support. And so here, earlier this year, I got 6 different ESP32s all working concurrently on the iPhone there. We talked about the ability to change your own software. So say, for instance, you have a cryptographic library, and here's a one-line command that turns on post-quantum. How many guys know about post-quantum? A lot of you? And so here you have an SSL connection, and you can actually turn on post-quantum. Well, how do you know that it's actually doing post-quantum? Well, of course, there's our friend Wireshark, and you'll see here under the key extension, right? You see we're doing Kyber 1024 key exchange between an ESP32 and a Linux client. So one of the ways to monitor ESP32 packets is, you guys are probably familiar with switches and on your basic network hub, that they'll filter packets, so you can't just plug your computer into the same Wi-Fi hotspot and be able to think you can sniff the packets from the ESP32. So one of the things I took as an edge router. If you have a router that supports port spanning, you can span 2 ports together, and you'll see between the Linksys router here and this bridge here in my ISP, I span those 2 ports and I plug my laptop into the Ethernet, and I can see the packets passing between the Wi-Fi hotspot that the device under test is connected to and my ISP. If you don't have one of those, if it's a little too complicated, you can get just a plain hub that does not do switching. You can buy an ESP32 that's got a wired Ethernet connection, and then you just plug your computer into the same hub, and you can use Wireshark. We talked earlier about adding features to a product. And so one of the fun projects I have here, SSH on a stick. So inside of my edge router, there's a header there that's a UART. And if you want to be able to add a feature where you can SSH into that UART over the network, I have an example there that you can do exactly that. The SSH project, it also works on the ESP8266, a little bit slower. Doesn't have the cryptographic hardware acceleration, but it does work. Tasmota, if you guys heard of Tasmota? So yeah, a couple of you. It's pretty amazing. It's a huge ecosystem of doing just what we're talking about, of repurposing ESP32 projects. There's a ton of existing products that people have gone and reverse engineered and documented and have sample code available. And so I did that. I went out and I found what I thought was a really great idea. I thought I would try one of these Wi-Fi light bulbs that I found out on the Tasmota site. And you would never guess by looking at the product that there's an ESP32 in it. It's a light bulb, right? And so this is what I thought I was going to get into, where there's you pop off the cover and there's a bunch of goop that scrapes out surprisingly easily. And you see here, this is a picture from the Tasmota walkthrough, so you kind of know what you're getting yourself into before you jump in. You see the GPIO pins that are there. But when I bought mine and I dug out the goop, so this is what I found. And so, yeah, that wasn't very cool. So you see on one side what I was expecting, and on the other side what I actually found in my version of the light bulb. And so, yeah, so some of the things you're going to want to ask is when you're reverse engineering things, how easy is it really? And so clearly that light bulb for me, that was not something that you can practically get in there and reprogram it. By the time I took it, would be able to take it out, it's probably not going to be a reusable enclosure anymore. And so one of the ways that I could have avoided that mistake is the FCC has really a treasure trove of documentation available. And so you find the FCC ID for a given product. You go out to the FCC site and you see where it says you type in the first 3 or 5 characters. And so I did that, and I didn't find anything on the first pass. But if you type in the 5 characters and then the rest of the product code, you'll see that, this product actually is listed at the FCC website. There's 2 different ones listed here. There are many different pieces of technical documentation available for public consumption, and one of them is internal photos. And had I seen the internal photo that showed the PC board at a 90-degree angle from what I was expecting, I might not have even ever ordered one for the purpose of trying to turn it into something else. And so you say, oh no, so we're not going to actually see anything that's actually useful. Actually, no. So at the other end of the spectrum, this Shelly device here, it's available for a little bit more than your typical dev board. It's basically something you can put in. You take the faceplate off of a light switch in your wall, and you can wire this in. You see there's 4 different switches there, so you can actually control a light switch using this little relay instead of walking up to it and flipping the switch. The really awesome thing, unlike needing to go out to the FCC site and trying to reverse engineer and dig for data. These guys at the other end of the spectrum, they're proud to announce that there's an ESP32 inside. It tells you how much flash is available on their website. But the thing is, it only works with Alexa, and we're here to talk about repurposing, right? We want to have this device work with something other than the Alexa. Even more awesome, they've documented, not only do they have a really cool documentation page that tells what's inside, but they even pull out a header and label the pins for you. So you don't even need to figure that stuff out on your own. And so you see you can pop off the cover, and there's the header. So you could actually reprogram this even without opening it up, right? So there it is, and it's manufacturer documented. I think everybody should be doing things like this so that, so some years down the line, you want to repurpose it, you can. Reminder about safety. So the Tasmodo site has a lot of good reminders on safety. So one of the things about the ESP32 is power. So there is a brownout detector, and if you have a marginally powerful supply that just doesn't, it works, but as soon as it starts doing something really intense and all of a sudden your board reboots, there's a brownout detector, and so your ESP32 will sometimes undesirably reboot. So the little TTY USB devices, even though there's a power supply that looks like it's available, it's not enough to actually power a device. I think I might have toasted mine just while experimenting with that, and so you can just hook up 2 of your USB TTYs, you reverse the transmit and receive, run a couple of PuTTY sessions, and make sure that it's still working. So initially I used another ESP32. I used this ESP32S3 to power my Shelly board. I didn't yet have any sort of connector, so I tinned the wires here. You might not be able to tell from the scale, but those are the 1.27 millimeters, so it's really tiny. And so the wires, tinning the wires, they just barely fit in there. But really, if you're going to start doing something like this, get yourself a little adapter. This makes things just vastly easier. It's much more reliable to convert from our typical DuPont headers to the 1.27 millimeters. Get yourself a breadboard power supply so you can power the device that you're reprogramming. Not all breadboards are equivalent. So you see the one board on the one side, you see it fits just perfectly into my breadboard. The one on the other side, not so much. I saw this. I thought this was a really cool idea. This has a power plug in the back for a little wall wart. This is a USB breadboard's power supply. I thought this was a really cool power supply to use. And so here's kind of the final product here. So I have my adapter, the Shelly board, the power supply, and the USB TTY. And so unlike the dev boards, where when you're programming them, all the logic's built into the USB, you just run some commands and it just magically does things. If you're programming an ESP32 with just the transmit and receive lines on, for instance, the USB TTY, you need to hold the GPIO 0 down from power up. So you ground that wire, you power it up, it's in flash mode, you run the flashing, and then you remove it and you reboot. And so these are, if you're going to not use JTAG program, you're going to program from a command prompt. This is all well documented out of the Espressif site. And so when you do, you should see something like this on the Apple HomeKit screen on an iPhone. You'll see there's a HomeKit LED, because that was the example we're using. So it's not a certified, it's not an official Apple product. It'll give you a warning. You just click on the Add Anyway button. This is the default code. That you can change that in menu config. The last digit here is a 3. You wait a short time for the pairing to complete. You'll see this on the UART, on the output here, and you'll see that it was successful down at the bottom here. So the COM port, like when you press the button on the iPhone, it'll actually tell you in the UART what's going on. And in this case, with the Shelly board, there's a little LED on the board, and it's we talked about earlier about the reverse logic. And so when it's turning on the GPIO, it actually turns off the LED on the board. And so that's another reminder to just pay super close attention to the logic levels. And so here it is all in action here. And yay, it's all working. So we talked a little bit about WolfSSL earlier. If you want to learn more about the cryptographic libraries, I did a webinar that you can see out on YouTube here for getting started specifically with WolfSSL and the ESP32. I had a presentation earlier this year with Espressif at DEF CON 24. This is also WolfSSL, but this is specifically doing TLS 1.3, like how to do TLS 1.3 from the ESP32, and this goes into much more detail on some of the programming to do that. And beyond the ESP32, there's of course many other projects. Hackaday inspired me a bunch of years back with this project. Johan Conflo, he's got a really cool open DPS. Hello? Oh, there we go. Has a really cool open DPS product here, open source project. And what it does is you can basically put a different UI on this device here. And so thank you guys all for coming. This was my first ever presentation at a conference. I want to say thanks to Hackaday for inviting me here. Of course, the SupplyFrame folks for sponsoring this. WolfSSL, I get to work with a lot of really smart people, and I've learned really a lot there, so I appreciate everything from those guys. But really all of you guys and all of the folks that share their work with open source. I mean, none of the stuff that I did today on stage would have been possible without all of the awesome projects shared and open source. So yeah, standing on the shoulders of giants, thank you to everyone that supports open source projects and appreciates the value that that gives really to everyone. I want to thank my grandparents. They would have been proud to see me. They bought me, the 150-in-1 electronic project kits when I was like 8 or something. And I went on and got a degree in electronic engineering, and they would be super proud to see me up here on stage. I also want to thank my wife that she listened to me practice this presentation so many times that she could recite it. I will have all the presentation materials, the slides available at this website. If you guys want to send me any questions, you can. I think I'm nearly okay on time. And so, yeah. So, questions?
The JTAG stuff, how much does that speed up your cycle time when you're doing stuff with your UI?
Oh my God! I mean that. Pardon?
Please repeat the question.
Oh yeah. So he was asking, and it's such a good question. It's practically a seed question, when somebody gets up and nobody asks any questions. So thanks for asking. I say, how much does it speed up the development process? It speeds it up tremendously. You can flash there's no way that I could flash a program on an ESP32 over the USB port anywhere close to the speed that you can do it over JTAG. It's immensely faster. And for me, as a software engineer, the ability to set breakpoints, I think you guys have all done printf debugging, right? You get to some point, and I've done that, right? Because it's convenient. There's nothing like an embedded device where you can pause, step into, step over. And so order of magnitude, in answer to your question, it's better in every way. There's no disadvantage, except keep in mind the JTAG is using GPIO pins, so you never want it, don't program those GPIOs to turn something on and off, because, and I've had a situation like that where you can have a really challenging time. Why isn't my JTAG working? So, but good question. It's such a good question. Joe gave me a couple of these to give away. Would you like one? Joey, come see me afterwards. Other questions? Anything? All good? Oh yeah, multiple questions.
Have you tried ESP Home?
I have not.
It's much better than Tasmania.
Really?
Much better than Tasmania.
Okay.
Please try it.
I will do that. There's a lot of things on my list of things to test drive. The cool thing about Tasmota is it's got a lot of reverse engineering documentation, but I suppose you could do them in concert, right? You go figure out what's on the PC board, where the GPIO pins are, and then, really, as soon as you can reprogram your ESP32, the ESP home, or whatever ecosystem you want. I mean, we all know once you have the source code, you can do whatever you want with it. But that's a great question. Good comment.
I needed the source code of Tasmota a bit, and it's not great.
It's not?
The ESP home is beautiful. Tasmota is Arduino source. It's not beautiful.
Okay. Thanks for that. I don't have any affinity for Tasmota. I just recently learned about it. Yes.
How often, when you open up a commercial product, do you find that the JTAG pins or the programming pins are actually available?
You know, if it's not a matter of if they're available, because you got to remember when the manufacturer made the device, they had to flash it somehow, and so typically there'll be a row of pins or a little 2x3 header. It might not have any pins attached to it. They might have used pogo pins, but one way or the other, the manufacturer needed to put software on there in the first place. And so as long as you can physically get to it, the pins will be there one way or the other. The trick is finding it sometimes. But a good question, yeah. Other questions? Cool. Well, thank you so much.